Question 25. Which of these following linear system of equations has infinitely many solutions? This question is not hard. It's actually very simple. But you have to be able to pick out the key statement. It's a system of equations, also called a simultaneous equations. But in this case, it has infinitely many solutions. This differentiates it from the previous ones we've been solving. You can solve a system of equations question using elimination, substitution, and you can also solve graphically, although there are other methods too. But these are the three basic methods. To best understand this statement, infinitely many solutions, we have to show it graphically. So let's say we have our xy plane, this is our y-axis, and this is our x-axis. Standard, if it's one with a pair of solution, you can have the first line like this and the second line like this. So where the two lines meet, that's the point of intersection of the two lines, carries the solution. If you trace it to the x-axis, you get the x value. And if you trace it to the y-axis, you get the y value. So let's say here, at this point where the two lines meet, you trace it to the x-axis, it lands at x is 1. That means the x value will be 1. And if you trace it to the y-axis, and it also lands on y is 1, then the y value for the answer is 1. So in this case, you have a pair of solution. That means you get the xy pair. Hope you understand. Now, going back to the question, infinitely many solutions. That means you have non-ending solutions. Let's say this is the first line. Imagine you have this as the first line. Then the second line, rather than cross it, it's on that same line. So you have a second line on the first line. In this case, you have the two lines touching all through. That's what it means to have infinitely many solutions. And in this case, these lines have the same gradients and the same y-intercept. They both cross the y-axis at the same point. So that's when you say a system of equations has infinitely many solutions. It's just the same line. Now that we have established what it means for a system of equations to have infinitely many solutions, that is, you can say in simple words, the same line, or you can say a line is on another line, meaning they have the same gradient and the same y-intercept. We can then move to the next step of solving this question. To complete this question, there are actually two methods: the shortcut method and the standard method. Let's start with the shortcut method. The shortcut method has to do with studying the options. If you look at the first option, you have 2x plus 3y equals 13. If you look at the second equation of the first option, you have 3y equals 9. If you look at the second option, that's option B, you have 2x plus 3y equals 13. Same for the third, same for the fourth option. They all have the same first equation. That means 2x plus 3y equals 13 is actually the first equation. So you can say you have 2x plus 3y equals 13 as the first equation. To create a second equation that will make the system have infinitely many solutions, you would have to multiply the equation by a value. For example, you can multiply the equation by 2. So all of the values will be multiplied by 2. It could be 3, it could be 4. It could be -1, it could be -2. It could also be a fraction. So once you understand this, you can apply the shortcut method. Going back to the options, A will never be the answer, because you have 3y here, you have 3y here, which means there's no increase or decrease, and there's also no value for x. If you look at B, you have 2x, below you have 4x, that you're increasing from 2 to 4, and such increase has to do with multiplication. So you multiply 2 by 2 to get 4. If you multiply that same 2 by 3, you're supposed to get 6, but here you have 9. That means this is not a system of equation that can give you a solution that has infinitely many solutions. Looking at the third option, you have the coefficient of x here is 2, the coefficient of x here is 4. So 2 to 4, you multiply by 2. Then you go to this 3 to 6, you multiply by 2. That's correct. Then we consider the constant outside. That's 13. You have to also multiply 13 by 2. You're supposed to get 26. Here you have 10. This is also wrong. Note that in this case, if 2 works for the first one, that's multiplying the first equation by 2 to get the second equation, it has to work for all of the values. And note, all of the values will have to be arranged in order. That is, you are having the x first, then the y, then the constants on the other side of the equals to sign. You can have the y first. You can have them all before the equals to sign, but they must align. Let's go to D. The coefficient of x here is 2. The coefficient of x here is 4. You multiply 2 by 2, you get 4. You multiply 2 by 3, that's the coefficient of y, you get 6. You multiply 2 by 13, you get 26. This is the right option. D is the right option, because this is still the same as this. If you divide this second equation by 2 or multiply it by half, you get equation 1 back. That's how you know a system of equations has infinitely many solutions. Hope you understand. That means this 2x plus 3y equals 13, which is equation 1, must be multiplied by 2 to get equation 2. And if you multiply equation 1 by 2, you get 2 times 2x will give you 4x. 2 times plus 3y will give you plus 6y equals 2 times 13 would give you 26. So that's how to solve this question using the shortcut method. Hope you understand. It's not really very hard. Just make sure they are lined up the same. In this case, the x first, then the y. Then on the other side of the equals to sign, you have the constants.